In this video, we're going to talk a little bit about statistics. I'm going to call this Statistics Part 1 because we'll be talking more about other statistics later in the course. This is just what we're going to get started with. The first concept I want us to talk about is that of the population. Typically, we come using statistics, we have something that we want to study, and the population consists of the items or the individuals that we want to study as a whole. The member, it's a set, but it could be a set of people, it could be a set of objects. It represents the entire thing that we want to study. And typically the population is too big to study on its own, so we'll take a subset of it, which we will call a sample. Okay, so we use a sample as a means of studying the population. So as an example of this, I'm going to think of, say, the set of all bags of M&Ms as a population. And to kind of get a handle on this, say M&Ms are made in different sizes of bags. There are fun size bags. There are share with a friend size bags. Think of one particular set of sizes of bags produced, say, at an M&M's factory on a particular day. That would be the population that would be under study. And connected with that, we would be wanting to take a sample to perhaps study the quality of the M&Ms produced on a particular day. So here we have picked out 10 different samples of 10 different bags, and these 10 bags constitute a sample from our population. Okay. Okay, now associated with a random variable, with a population would be a random variable. A random variable, it's actually a function. It associates to each member of your population a number. Okay, and we can be very, very imaginative in coming up with ways that numbers can be associated to members of a population. An example here, we go back to M&Ms. Let me go back in our M&Ms, we say open a bag, an element of our population, a member of our population, and count the number of reds. That is a random variable. The number of red M&Ms in a bag of M&Ms is a random variable because it associates a number with the member of the population. Okay, so here our first bag has 1, our 8th bag will have a value of 2, and like that. We could also say, hey, the number of orange M&Ms constitutes a random variable, and each of these bags having a value 5, I think that may be 5 again, 3, 7, etc. Okay, these are so the number of M&Ms of a particular color is a random variable. Here we take the bag being the member of the population, number of a particular color being the random variable. Okay, a parameter, okay, is a number that's associated with a population. Okay, So not a member of a population, but with the whole population. Okay. An example of this just would be, say, the size of the population. It is a parameter. Okay. That's not a particularly, well, I guess it will be important, but it helps us in getting other parameters. Okay. Examples. Okay. We have two that we are going to learn more about. The mean of your random variable on a population and the variance of a random variable on a population will be parameters of that population. Okay, so you have a random variable x. Okay, I'm gonna put some stuff in color here. A random variable that we label by the name x. Each of its values, okay, is denoted separately here. Okay, x sub 1, x sub 2, x sub 3, x sub 4, up to x sub n. Recall, x sub capital N is the size of our population. We take each and every member of the population, we add the value for the random variable x together, and then we divide it by the number of that we have in the population all together. That gives us the mean of that random variable. The mean of the random variable is a parameter for the population. This right here, okay, this is a different notation for the same thing. This letter right here is the capital Greek letter sigma, and it tells us that we're supposed to add up stuff in this way right here, starting with a value of a subscript equal to 1 and ending with the value of the subscript equal to n, going from n to 1. Okay. Okay, another parameter, okay, is the variance. Okay. The variance is similar to the mean and how we obtain it. Because what we do, it's actually a mean itself. We're taking a mean of another random variable. We take our original random variable x and subtract from every value the mean. Then we square that. This is a new random variable. We take its average. It gives us the sample variance. Okay. This letter here is a lowercase sigma. It looks very different from the uppercase, doesn't it? And it looks like an O with a baseball cap on it. And it has that little 2 up here. That little 2 is actually a square because we're squaring the random variable. And this is the sigma notation for it. But again, notice we're dividing by the number of items in the population. And so it's a mean of a different random variable on this same population. Okay. Now, you've heard of statistics. This is what an actual statistic is. A statistic is a number associated with a sample. Okay. And we'll let little n denote the size of the sample. Okay. Again, we have, and statistics are typically used to estimate parameters. Okay, and so 2 examples that we will have. Okay, one will be the sample mean, and the other is the sample variance, and associated with that is something called the sample standard deviation. Okay, so the sample mean, okay, we take the values of our random variable in the sample and add them up and divide by the number of numbers. See, this is very similar in the means of computation to calculating the population mean, and it naturally it will it is an estimator for that. And the idea is if you take enough samples that they'll tend to be close to the mean. We'll talk more about that later in the course. Then the sample variance, which is similar to how the population variance, how the actual variance is calculated, but I'm not dividing by the number n, the number of items in the sample. I'm dividing by n minus 1. It needs to be done this way so that it will be an estimator for our parameter, the variance. And we get the standard deviation and the sample standard deviation just by taking the square root. We take the square root of both sides and we lose the squares in the exponent. Okay, that's what square roots do. They get rid of squares in the exponents. And so we'll have some exercises to show how we actually calculate this.